Students, in last class we discussed about the different types of filters used in power supply circuits. So we know the first block in the power supply is rectifier. So the output of the rectifier is pulsating DC. It's a combination of AC plus DC. To eliminate the AC components in the pulsating DC, we are using the filters. By using the filters, we are considering the output as pure DC, but it is fluctuating DC. To eliminate the fluctuations in the DC output, we are using the voltage regulator. So the ultimate output of power supply is stable DC output. To get the stable DC output or constant DC output, so here we are using the voltage regulator. So the one of the main application of Zener diode is voltage regulator. Today we will discuss about the voltage regulator circuits. It is an electronic circuit which is designed to keep the output voltage of your power supply nearly constant under varying input voltage conditions and varying load conditions. Otherwise, you can say simply it is an electronic circuit which provides the constant DC output voltage irrespective of fluctuations in the AC voltage, AC supply voltage. These regulators are basically classified into two types. One is linear, another one is non-linear. In non-linear, these are the switching regulators that are switch mode power supply regulators. And coming to the linear, again it is classified into two types that are regulated using discrete components. That means these linear regulators are constructed by using the discrete components. And second one is IC regulators. So these IC regulator is nothing but integrated circuit. So whatever the electronic components used in the discrete whatever the discrete electronic components used in the linear regulator, they all are fabricated in a single silicon wafer. This is integrated circuit. These integrated circuits are again classified into integrated circuit regulators are again classified into two types, that are fixed voltage regulators and other one is adjustable voltage regulator. So in this adjustable IC voltage regulator, the output of this voltage regulator can be varied. So you can vary any one of the voltage in the range. Similarly, fixed voltage regulators. So here it is an integrated circuit. Here these are available in the form of two types. One is 7866, another one is 79XX. This 78XX series indicates the positive voltage regulator and its output is always constant. So the double X indicates the output of voltage of the IC. So if I am considering the 5 volts as output DC, then the IC number is 7805. If I am considering 12 volts DC output, then it is 7812. That double X indicates the output DC voltage of that IC regulator, and 78 indicates the negative voltage regulator. The 7905 indicates the output voltage of this IC 7905. It is negative 5 volts voltage regulation. Clear? This 78 indicates the positive voltage regulation and 78 indicates the negative voltage regulation. This fixed voltage regulation means that IC provides only that particular output voltage only. So we cannot vary. And coming to the regulator using discrete components, that means these regulators are constructed by using the discrete components that are individual components. So which can easily remove from the circuit. Now that regulator using discrete components are again two types, that are shunt regulator and series regulator. That regulating element, when we are connecting in shunt, that is shunt regulator. When we are connecting in series, then it is series regulator. So shunt means parallel, that series means we know that regulating element is connected with the series with the load resistor. Clear? That means load resistor means where we are we are taking the output. So here our voltage regulator is Zener diode. We are considering our regulating element as Zener diode. this zener diode is connected parallel to the load resistor, so this one is shunt regulator. That means it is connected in the shunt with the load resistor, so it is zener diode as shunt regulator. Yes, so we already know this zener diode is acting as a regulator when it is in the reverse bias, or when it is in the reverse bias condition, or in the breakdown region. Clear? So this zener diode is connected in the parallel to the load resistor, and we are using the series resistance. It is series current limiting resistor, so which is used to oppose the flow of, which is used to prevent the heavy current through the zener diode. So when you are not keeping the series current limiting resistor, then the current maximum current will flow into the zener diode, so there will be a chance to damage the zener diode. So to avoid the damage of zener diode, we are using the limiting resistor. This is series current limiting resistor. So here you can observe the zener diode shunt regulator. So here we are connecting the Vs. Vs is nothing but DC voltage source, which is nothing but the output of the filter. So it is fluctuating DC output. So it is variable one. So we mentioned it is battery with variable symbol. So this is output of the filter. Output of the filter is nothing but variable DC, and we are using the current limiting resistor to avoid the heavy current through the zener diode, and we are taking the output across the load resistor RL. So the current coming from the source is we are considering as a IS. So the current is divided into two parts. So one is current entering, current passing through the zener diode, and current passing through the load resistor. So we can say the total current in the circuit Is is equals to sum of current passing through the zener diode and current passing through the load resistor. So we can say by applying KCL, Is equals to Iz plus IL, and similarly V0 equals to Vz. So from that we can write Is equals to, by applying the KVL here, Is equals to Vs minus Vz by Rs. So here, for the proper operation of current through, for the proper operation of voltage regulation, so current through the RS must be at least equal to the sum of zener knee current and specified load current. This zener knee current is nothing but, now this zener diode is connected in the reverse bias. You can observe the anode of zener diode is connected to the negative terminal of the battery, and cathode of zener diode is connected to the positive terminal of the battery, so it is in reverse bias. So with the zener diode in reverse bias, we know the minor or small amount of current will flow before the breakdown. That current is called zener knee current, or Z minimum current. So we can say Iz minimum current. So when it is entering into the breakdown region, that means the sudden current will flow. It is nothing but maximum current. So that is called Iz maximum. So it is already discussed in the zener diode characteristics. So for the proper operation of zener diode as shunt regulator, so we must follow the Vs is greater than or equals to Vz. Vz is nothing but zener breakdown voltage Vz plus Iz minimum plus IL into Rs. Here Iz minimum is the zener knee current, IL is the load current, Rs is the current series limiting resistant. Operation of power dissipation in zener diode should not exceed its power rating. Whatever the power rating of zener diode, the power dissipation must be less than the power rating of zener diode. If it is more power dissipation in zener diode, that means more than the its power rating, then what happens? Again, zener diode may damage. Yes. So the maximum allowed zener current is calculated from power rating Iz max equals to power rating by Vz when considering the resistance of zener diode is 0. For the safe operation of zener diode, this Is is less than or equals to Iz max plus IL. Similarly, Vs is less than or equals to Vz plus Iz max plus IL into Rs. If Rz is not equals to, then we can calculate the Iz max is power rating equals to I square Z max into Rz plus Vz into Iz max. So in regulator, Zener current should lies always between the IZ minimum to IZ max. So these regulators provides the line regulation and load regulation. So these regulation generally with varying input voltage and regulation with varying load voltage. So we need to maintain the constant output voltage when input voltage is varying, and second case we need to maintain the constant output voltage when load is varying. So two conditions. So first condition, I am assuming the input voltage is varying, that means supply voltage is varying. Then what happens? So we can say whatever the V naught output voltage is always equals to the voltage drop across the generator, that means breakdown voltage Vz. So in this we can say if supply voltage increases, first case I am assuming input voltage is increases, that means supply voltage is increases. So when supply voltage is increases, then what happens? The total current I increases, total current I increases, IS increases, but IL constant. So when we are assuming the input supply voltage is varying, then we need to consider the load current is constant. So IL is constant as Vz is constant. Hence the current Iz increases to keep IL constant. But as long as Iz is between Iz minimum and Iz maximum. Yes. So now the output is always equals to Vz. Clear? So we can say input voltage changes and output is always constant. So the output of the circuit is always constant irrespective of the input voltage changes. Clear? Similarly, if V decreases, then current I decreases, but to keep the load current IL constant, Iz decreases. As long as Iz is between Iz max and Iz minimum, the output voltage remains constant. So, if I am considering the second case, that means my regulation with varying load. Now I need to assume my supply is constant, that means Vs is constant. So, when load resistance is decreases, IL increases. To keep Is constant, Iz decreases. But as long as it is between Iz minimum and Iz maximum, the output voltage V naught will be constant. Clear? Similarly, if RL increases, so load current IL decreases. To keep I constant, Iz increases. But as long as it is between Iz minimum and Iz maximum. So otherwise you can say this regulation is two types. One is line regulation and load regulation. In line regulation, the output voltage is constant irrespective of line voltage changes. In line regulation, load current is assumed to be constant. So we are considering the line regulation. It means the output voltage is constant even changes in the supply voltage. So in this we need to assume the load current is constant. So in this the line regulation changes, that means when line voltage, in this line voltage increases, that means Vs also increases. When Vs increases, Is increases, that Iz also increases because load current is constant. So this load voltage across the Zener diode does not change and V naught remains constant. And second case, whatever we said previous, so now it is named as load regulation. So it refers the output. It refers to the output voltage is constant even if load current changes. So here load is varying. That means we need to consider the input supply voltage or line voltage is assumed to be constant. So now my Vs is constant. Then what happens? Now Vs is my constant. Is is also constant. As if RL decreases, load current increases, then Iz decreases. But voltage across Zener diode does not change and V naught remains constant. So this is called load regulation. Sometimes you may hear new term, that is temperature regulation. So the output voltage is constant even temperature changes. Clear? So why? Because our Zener diode is also temperature dependent device. So we may observe the temperature regulation also. Clear? So thank you.